Okay, so this is the second session. So this will be a technical presentation, technical demonstration as well. So in implementing our microservice technology, we're using this molecular framework. Uh, Maybe it's a little bit difficult unless you're familiar with Node.js. So I highly recommend start with Node.js first and then try to go with molecular uh, framework. So it's very straightforward to implement, but let me demonstrate to you first. Remember in our first session, I discussed about the service discovery, wherein the different microservices communicate using a messaging called the NUTS. This is NUTS. So this is a very high-speed open source messaging system. It's not only used for microservice, but even for IoT, Internet of Things. So you can use this to basically use for any messaging, how you want to, like the idea of NATS is if you have different microservices running on different location, they can actually communicate with each other by sending messages across. Very high speed, high performance platform, and it's widely used even by the big companies like VMware, Sony Ericsson. So big companies like this are using this for not not just for microservice architecture, but also for cloud applications and IoT. So let's start. So this is a simple. It's when you write the code for implementing the microservices, it's quite easy. So if you look at on the right, let me know if you can see my screen.
Yes, sir. That you can see the
Yeah. So if you look at on the left side, you can see here a folder where in the name is services. And inside the services, we have, as based on our diagram, we have three different services running. We have the authentication service, we have the gateway service, and then we have the core service. The core service is our service that allows us to implement business logic. For example, in our example here is allows you to save a customer and to query a customer. Now, project folder structure is quite easy. Just put all your services inside the service folder. Now, if you might be wondering, this is a simple single project with all the services inside. So how come it can be deployed and distributed? So let me demonstrate that to you. One thing, by the way, is the recommended environment for any API and even the Kubernetes cluster is a Linux. So this will be actually part of also your learning process that you should be able to learn how to utilize Linux. One of the advantages for Linux is it's really high performance. It doesn't require very high cores of CPU or high memory. Even a single core with 2 gig of RAM can run your API. That's how efficient the Linux environment is. Not also considering that this is open source, this is free. And the most popular version of Linux is Ubuntu. If you can see here, this is the Ubuntu Linux. It's free, it's open source, it's very fast, and it's very systematic when managing the memory resources. Anyone in the development team familiar with using Linux yet?
Yes, sir.
Okay, that's very good. Okay, so let's start. So I have a project. Later on, I will give you access to the server, but I have here a project uh, called the Service API. And this is basically the project file, which is exactly the same as this one, the source code. This is just loaded in Visual Studio Code. But if you look at the process, this is actually a website. This is now another way to actually write your code. Not only we're developing distributed application, even writing code doesn't even require you to set up so many things. In this case, I can access my source code from the browser and I can write my program from within the browser. I don't need to install any software on my machine. Meaning, even if I am in an internet cafe, I can still continue working. I can write my code. I can develop my code. This is the web version of Visual Studio Code, and it is already running on my server. Let me show you that here. Okay. In our particular in this particular server, I'll just disable the authentication. But in if you want to use it for real development purpose, you have to enable authentication so that nobody can access to your source code. But for this presentation, I just disabled the authentication so everyone can actually access the the source code. In fact, if you want to try it now, you can see here, you can open your browser. Just point your browser to dev.networkgateway.net port 8080, and you can see the project file. So that's how easy. That means even developing is distributed. You can write your source code from anywhere you want. Okay, so you can access. But anyway, as soon as we have our group chat in the Rappi, I can send you the link, or you can just copy the access the link from here. Okay, so you don't really have to deploy or install anything on your local machine. You can start writing code, but sometimes other developers prefers to have a local environment. That's fine. You just download the source code, install the dependency, and you can run it right away. Okay. Now let me demonstrate. The first question I have, well, this is a single project file, so how can I deploy this in a distributed way? Because every time we deploy this one, it will be deployed as a Docker image, as a Docker container. Let me demonstrate that. Okay. So I have here my project. By the way, since recommended by Babi-san, we will be using MySQL. You can also access the MySQL from here. I will give you the credential, but let me just show you that. So you can connect to the MySQL. Let me know if the font is too small or you can see it. Please let me know.
I can see it clearly, sir.
Okay. So I can connect to the MySQL. The, the username definitely is root. Password is I will send you later on. Okay. Now, maybe some of you are not familiar with Linux system yet, but if you want to show the database, here I have an SIOI database here. This will be used for our prototype application. You can connect to this database. You can add structure later on, but for demonstration purposes, we only have one table. We will have to use the SIOI first. Okay, so we only have one table, customer, and the basic structure for customer is like that. Very simple. The reason why I'm showing this to you because I will explain to you the concept of ORM. Maybe you're not familiar yet, but the idea is ORM means object relational mapping. Remember, in our database, we have tables and field. But in our source code, we have classes and object, right? So those are two different things. We have database tables and fields, and we have in our application we have classes and object. Now to be able to map those, we use a concept called ORM, object relational mapping. One table will be mapped to a class, and then each of the fields will be mapped to a class property. I will show that later on. But just to show you, this is our data structure. You can see this. Now, you might not be comfortable with using command lines. So you can actually connect to the server as well using any external client. Let me show you that here. Okay, so I have an SIOI table with a SIOI database with table customer, and I have also the structure. Okay, so either way, which one you prefer? You want to use the GUI or you want to use with the command line? For me personally, it doesn't matter. I can use both. But sometimes if you are in a production environment, normally, this is one thing I would like to explain. When you are in a production environment, if you use the GUI, normally what you will do is you will expose the database outside so that your GUI can actually access your database. In a production environment, we don't want to do that. We don't want to expose the database outside. Keep it internal, keep it safe from outside access. That's why in a production server, it's ideal to use the command line. We don't want to have anybody have access to the database. But since this is a demonstration purposes, that's why I enable the remote access so you can access it from anywhere. But again, as a warning, don't expose your database outside. Keep it internal. Nobody should be able to access your database from the outside. Okay, so that's a very important warning. Okay, so we have a SQL database here. We only have one single table, but this is just to demonstrate how we can save and read information. Okay. Now, just to show you, let me show you that we don't have any Docker container running yet. Let me stop this one. Okay. Okay, so none, it's empty. So if we want, remember the question is, we have a single project, but we define the different services. So what if we want to deploy them? So I can actually deploy it as a Docker images. Don't worry about the command line because all the command lines can be seen from here. Let me show you. There is, in every Node.js application, there is always the package.json file. This is where you can see all the commands here. So if I want to compile my project into Docker, I can use the DC app here, which actually execute the Docker Compose. Docker Compose this is the Docker build. It creates the build of your application. Okay, Docker Compose down is actually it will stop all the running Docker images. But don't worry about the commands later on because you can review it from this file, the package.json. Okay, so let me compile. Let me compile the source code first so we can run it later and just test. Now, if you look up here, as I explained earlier, Docker itself has a network internal to the Docker system. That's why if you look at the log, it's actually creating the network for the internal Docker. And then this particular network will be exposed to the Docker Kubernetes cluster later on. But that is when you define your Kubernetes cluster. Okay, so it will actually compile your source code and create the Docker image. What is a Docker image and what is a Docker container? So Docker image is your main build. So every time, it's something like, I think you're familiar with the class. Docker image is your class. And when you create an instance of the class, it becomes an object. That is your Docker container. So meaning a Docker container is an instance of the Docker image. Okay. Okay. Now it's done. Now I will show you. If you look at that, so we have here core service, we have the authentication service, we have the gateway service, and we have also our NATs and the traffic. Remember, we have our diagram earlier. These are running independently on different Docker container. In our example, since this is a single cluster, we don't have a Docker Kubernetes. They are running on the same machine. But once we deploy this in a Docker Kubernetes cluster, this can be deployed on one or multiple machine controlled by the Kubernetes cluster. Okay, so you can see here, once you deploy your application, it will be running as different Docker container, running independently, and sometimes even running on different ports. Okay, but this is our production environment. So let me show you first. Let me stop this one. Let me stop this one and let me show you first the development mode and how easy is it to actually monitor your API. Okay, so we can verify nothing is running. But in development mode, we have to run the nuts manually. Okay, just to make sure that we have the nuts running here. We have the nuts running now. Now let's try to run our API and make a sample call. Okay. We are running in development mode, and I will also explain later on what's the difference between running in development and in a production environment. Let me just, I'm already running out of memory. Let me just stop for a while. Hmm. This particular virtual machine is very small memory, so I have to stop this one first. The Visual Studio Code. Because as I explained earlier, you can run the service API in as small as 1 gig of RAM or 2 gigs of RAM or one CPU core. So it doesn't really matter. So let's try to see if I still have memory. Okay, now I have enough memory. Okay, now we have run our API, but the question is, how can I access this information? So first thing, the reason why we are running in development mode is because you have access to the CLI. CLI means command line interpreter. So from the command line, I can type several commands. First, for example, I want to see how many nodes is running in my server. Right now, I'm only running on my single machine on one single node, but you can see different nodes here. You can see. So this information, I have one single node. This is the IP address, and this is online state. And you can see also the metrics, the CPU consumption. So every microservices maintains a resource metrics so that it can be monitored by the service gateway for the load balancing purpose. Now I can see that I have 4 services running, and I can check. Okay, so you can use the nodes command to check how many nodes. If you're in the cluster, there could be multiple nodes running here, but since we're using on a single machine, I can only see one node. But we can see also how many nodes, how many services is running. Okay, you can see here that I have, this one is already predefined. This is the node engine, but I have 3 basic nodes. Authentication, we have the core and the gateway. Now, if you notice in the last column, you also have how many nodes is this particular service running. Remember, in a cluster, you can have maybe core services can be running on 3 or 4 or 5 nodes. It depends on how you define your policy in the Kubernetes. Right now, it's just 1:1. 1, 4. Now, again, just like the question earlier by Lou, I think it was Lou who questioned. If you look up here, each of this one is running on different instances, but they're actually inside the Docker environment. But they have a virtual node inside. This is the single node, but it is running multiple services at the same time. But if I have multiple nodes in my cluster, this one could be one node, another node, and another node, depending on how you want to distribute. Now, I know how many nodes I have. I know how many services I have. I want to check what are the different actions. Actions is what are the different APIs that I can call for this particular service. So I can see, okay. See, I have here several actions. I have a query customer, save customer, and you can actually see that from here in the startup. I have here the API. See, this is the post request. This is for saving customer. If you can see here, there's the mapping. So for saving customer, I will call a post method for this particular endpoint. If I want to query the customer, I will call this particular method, and this is a get method. By the way, I hope you don't mind me asking, anyone already familiar what is a get and post request?
Yes, sir. I think all of us
Okay.
know already.
Okay, that's very good. Okay, so how did I know this is my method and this is my request? I will show you that in the source code. Let me just run. Okay, so remember we have the gateway service. In the gateway service, so for example, this is the core service here. So I define different actions. If you can look at here, I group them into actions. So we have actions, events, methods. Let's go to the actions. And I have here different method. See, this one, this one. So what I do, if I go to the gateway service, I'll define the actions and convert into a path. So like this one. So I group them into different one. This one, the V1/core. If you look at here, it doesn't need authorization. That means I don't need to be authenticated to be able to access the API. So this particular API, node info, meaning node information, I can call this API and then map to V1 core, but I don't need to be authenticated. So this is the definition of the gateway. And what is this node info? You can see the source code from here, node info, and this will be the response. Okay. Now, if you look at here, remember we defined earlier uh, a protocol of how the API should respond. We actually have created a model for that. Can you remember earlier we defined of how the API should respond? We have the code, we have the description, the date. So we should follow a certain protocol of how you want to return. So for every call, it should follow this particular format. So let's start the call. For example, I want to call node info. Now node info, I declare in the gateway service to map to this particular API, V1 core. Okay. So node info V1 core. So alias is V1 core slash node. This is a get method, if you can see. Now you can see that back in our command line. See this one? V1 core node info is this is the equivalent API. So let's try to call that. And you can also monitor all the active. So this is the good thing with the development environment. The most important thing when you design an API, you should be able to monitor and trace the API call. That's why we have the CLI. So let me try. Okay. Remember this is our API, right? API slash V1 core slash node. And we don't need the authorization because it doesn't require us to authenticate. And it doesn't have any parameters. We just need to call the get method here and just call the API. And this is the node info. Now take note, I will explain later on. We have two development environment. We have the development and then the production. The development mode, you don't really have to have an HTTPS or SSL certificate. Just use plain HTTP, that's fine. If you want to use in a production, it is recommended to use the HTTPS for security purpose. That means it doesn't allow any third-party attacks or inject values into your API by injecting information because it's encrypted when being sent across the browser and the server API. Okay, so we will use the development server first. That's why you have. By the way, you might get confused what tool I am using. This is for Linux, but I think you're familiar with Postman. Postman is a browser application you can use in Google Chrome. It's a plugin to call the API. So let's try to call the API. Okay, so the name of the API. And take note, there are two windows open here. This one is our CLI on the left side, and this is the tool to simulate the client to call the API. So let's try to call. Okay. Now, if you look at here, the response, this is the response. If you look at the response in blue color, we follow the format. So code is 100, success, and we have a data. Data could be any object. And in this case, it will show you the node ID, which is development 2922. The reason why this is very important is sometimes you need to query when you send the API, which node is responding. Is it the Japan server? Is it the China server? You can get the node ID from here. And I don't need to be authenticated here. We disable the authorization because, as I explained earlier, this API doesn't need any authorization. And from here, you can see also the log. So you can monitor all the API calls from here. So this is service call. And this is the method being called. There's no parameter. If you look at the identity, it's empty because it doesn't require authentication. And this is success. Now, just to demonstrate, to show you that this is a valid call, let me copy the URL. Okay. And let's try to do that in the browser. Okay. Remember the get it's typical can be called directly from the browser, but the post you cannot do that from here because it requires you to pass a parameter. So here, can you see? I'm trying to execute. Okay, I'm trying to call directly the API, and you can see the response in JSON format. And you can see it's using its TTP call. That's why it's called not secured, because this is development environment. So you can execute the API from the browser to call the API and without need to pass the authorization. Okay.
Okay,
Later,
sir.
next is later on I will demonstrate what is the difference between this one and in production environment. Remember, once you deploy in production environment, as much as possible, you don't have access to the CLI. So we use what we call a dashboard. From the dashboard, you can monitor everything from API calls to your metrics to your different resources. Now let's try to call another API. So I have another API here for user information. Okay, let me show you the source code first. Okay, now this time, this is the API. This is also a get user information, but the only difference, this belongs to this particular path secure that requires authorization. So if I call it directly like this, okay, so let's look at the endpoint first, p1 secure and slash user, this one, get property. The problem with this is if I call the user information and I don't pass the authorization, I don't pass the authorization token, what will happen? Let me show you the log. Okay, so this is our CLI. If I call this one without the username, without a token, you can see unauthorized access, which generates a 401. HTTP code 401 is unauthorized. That's why you can also monitor from here. You get a 401 error. That means you cannot call this API unless you are authenticated. Okay. Now let's try to authenticate first. So in authentication, we use the concept called the GWT, JSON Web Token. I first and foremost, I would like to apologize. Some terminologies may be something new for you. Maybe some are too technical, but definitely you will learn it along the way as soon as you start learning the process. Okay. So authentication is I specify the username and the password, and I specify the type. Operator means the system admin, and sometimes the type is user, which I will demonstrate later on, which is an ordinary user. Okay. Now let's try to monitor from here. If I execute the authentication, what you can see is that you will be given an token here. This is what we call an access token. Once you are authenticated in the system, you will be given a token which you can use to actually access the succeeding API. So let's go back to remember we have an error earlier. I want to remove this one first. Earlier, we have an error for the authorization because we did not authenticate when we call the user info API. This is the user info API, by the way. If you can see on top, slash API slash version one, here's a user. So the way you authenticate to the user is you use the HTTP header. This is a standard. Whether you're using Molecular or other platform, you can use Angular. It uses the same principle. So in authorization, you specify the bearer and you specify the token. Remember, this token is the one that we got from the authenticate. So we include the bearer from here, and then we will authenticate, and then we will execute the user information again. Oh, token is invalid. Let's see. Okay. Okay. So what we do is we inject the value so that it's much easier. We inject the value from the authenticate method, and we get the token. This is the token. Either you can put it directly from here like that. Okay, so you can see also successful here. So the idea when you once you authenticate, you will pass the token in the authorization header and use the bearer and inject the token. And now you can be accepted. So now you can see the reply that the current user that is logged in is the system administrator. Okay, so this is an example of how you execute the API, whether it's authenticated mode or not. Now, another important aspect is once we deploy into production, we don't have access to the CLI anymore. Although you can still access, but the problem is sometimes you need to trace the API call jumping from. Remember, in our diagram earlier, we have the gateway, we have the authentication, but in the development mode, we don't have the gateway, but we only have the authorization mode. So let me show you that in the source code. Sometimes it's quite difficult to actually trace. Remember, it goes to the authentication and then it goes to the core services. Sometimes you need to do tracing. Tracing is a method to trace where the API is failing or how fast is the API responding. So that's quite easy to configure in Molecular. All you have to do is just enable the tracing here. See this tracing part, we can enable and we will see what's the difference. Okay. So we will enable the tracing and we have a handler here called the console. Console means the command line. I hope I can show you. But one of the feature for Molecular is there is what we call the hot reloading. Let me show you that. Okay. So this is my source code and this is my console. Every time I change something in the source code, like for example, this one enabled, I set this to false. You can see here it automatically restart to update to reflect the new update. That means before, in traditional way, every time you make changes, you have to run again and redeploy, run again and build, run again and compile. Here in Molecular, it's much faster to develop because every time you make changes to the source code, it will only update whatever has been modified and automatically compile by itself. So for example, I change this again to true. And then once I save, See, it all automatically update and restart. So it's very fast. You don't have to recompile. You don't have to rebuild, redeploy. Every time you make changes, automatically reflected. That is what we call concept called hot reloading. In the UI, the same. If you change something, automatically reflected in the UI. But we will discuss that later on. So this is only the API side. This is a very time-saving feature. You don't have to recompile. You don't have to redeploy. Everything will be reflected right away. Okay, so now we have enabled here the tracing. So what is the difference? Let me do that again. And let's try to call the API again. Okay, so I will call the same API user info. Okay, so I will run this one. Okay, can you see this one? Aside from the console log, you can now trace. So for example, the whole API was executed in just 64 milliseconds. First, it goes to the authentication service to authenticate the token. Very fast, it's only 962 microseconds. And then after it has authenticated the token, it goes now to the user info to execute the API, just 1 millisecond. It's very fast. And you can say the tracing from here. It doesn't look good because these are CLI, but I will demonstrate later on how to do that in the dashboard. You can trace every aspect of the API. You can monitor every API calls from here. Maybe we can do that. I will demonstrate that right now, but maybe let's just continue first, demonstrate. Now let's try to implement the ORM. Remember I mentioned about ORM, how we can map a database object into your objects and classes. So it's quite easy to implement. Okay, so all you have to do is just define the model. Here we have a customer, and then you just define whether this is string or this is a number. Okay, so I define a class. This is a basic class. So this is a customer class. This will represent my, let me just put this side by side. So remember, this is my table. I have the ID, name, department, email. I'll create a class that represents this particular table. So ID, name, email, mobile, username, password, department, and then notes. And then I create a policy, whether this is required, mandatory, this is primary key. You just define like this, very easy, straightforward. And then you will define which table it is mapped and what is the corresponding module name. So this is what we call the mapping. Remember that the table name is customer and the class name is customer with a capital C. That's it. That's easy. And all you have to do is just inject this in the connection. Okay. So I have on MySQL, I define a connection. Here, this is the IP server. This is the port number. 3306 is the standard port number of the MySQL. And you can define all the options. Now, take a look at this part. Pool. What is anyone familiar with connection pooling? And why this is very important? Anyone?
Maybe not. No one, sir.
Oh, okay. I think because because right now the way it works is the I'm not really sure, but I think Cold Fusion is not using the connection pool. So take a scenario. I want to query the list of customer. So the first step that the application will do first is it will connect to the database. It will authenticate. Once authenticated to the database, you will send the query, select statement, maybe, for example, get the query response, close the database, get the result, right? So it's very basic. Connect to the database, authenticate, execute the SQL statement, close, and then get the result. Every time you do that, you have to open the database, authenticate, close, get the result. You have to do that, and it's very heavy. That's why in a cloud architecture, we use a connection pool. How many is the minimum? How many is the maximum? So what is the connection pool? The idea of the connection pool is the application will create 5 channel, in this case, maximum of 5 channel, or minimum of maybe one. It depends. Zero means start with zero and then we create a new connection pool whenever necessary. So the idea is once I create a connection pool first time, it will authenticate, send a query, get the response. But after getting the response, connection pool will be put in the queue, connection pool queue. Next time, if there's another query, I don't have to authenticate, open the database, authenticate, execute the query. All I have to do is execute right away because I already have the pool, connection pool. You get the idea, right? I already have the connection pool. I have to do is just reuse them.
Yes, sir.
Okay, so it saves you a lot of time. It saves you a lot of resource, and it's actually execute your query much faster. You don't have to open, authenticate, close, open, authenticate, close. Connection pool is reserved there. It's open and it's being used whenever necessary. Now, if it's not necessary anymore, connection pool can be closed by setting the minimum. So, example, nobody is accessing, and I set the minimum to 1. It will only open one minimum and will create connection pool whenever necessary only. Okay, when the minimum is 1 and I have connection pool of 5 right now, it will close all the other connection. You control how many connection pool is open depending on the number of resources available for your machine. Okay, so this actually speeds up the process. Now, just to let you know, this is also cluster aware. So when I create a connection pool, it doesn't mean a connection pool to only one single database. If I have multiple database in a cluster, I can open one connection pool for cluster 1, a node 1, database node 1, database node 2, another connection pool, just to actually load balancing the connection pool. Now, remember, this is only for the database. This is a load balancing and connection pooling for the database. The API is also another load balancing mechanism. So you have multiple layers of load balancing to actually speed up the performance of your data access. Okay, you are already load balancing the API. You are also load balancing the database based on your cluster configuration. Okay, now let's try to save a customer. Let's say I want to register a customer. So let's try to look at the API. So I have here a core service, and I have here a save customer method. See, remember we create a customer class. If you want to save the database, it's very easy as like this. Customer that create, because we already have the cost. No fancy statement. You don't have to write like insert into. No. Use your class. Remember, we create the customer class and just execute the create method. Pass all your the information and it will be stored. Very easy. You don't have to think about how many SQL statements. The reason why ORM was created is suppose I want to migrate to another database, let's say Oracle. If you work with SQL statement, sometimes SQL statement in Oracle is different. They have Oracle specific queries. They have Oracle specific commands. But if you are using ORM, all you have to do is focus on this method and the engine will translate automatically into SQL statement based on your target database. So it's your application is universal. you can switch to Oracle, you can switch to Sybase without changing your source code because you are not using the native SQL statement. For example, in there's select from row num. Row num is the row number, but row num sometimes is not available in other uh, relational database. But you don't have to worry because you have to execute only the ORM statement and it will be translated accordingly to the target database. So this is the advantage of ORM. You are abstraction layer your object to be able to map to the database, but you don't have to worry which SQL statement do I have to do? How do I insert the database? Because it's being handled from behind the scene. Okay, so right now, quite easy. If you want to save a record, just execute the create. Now, if you want to query a database, even more easy. All you have to do is find by primary key already at the statement. See this one? Don't worry, there's a documentation what are the commands in SQLite. So let me show you that. Okay, this is the ORM method that we use. It can connect to most database MySQL. They have a documentation. I will send you all the information later on. You don't have to issue a native SQL statement. You can just use the basic commands from the SQLized and it will convert to SQL statement for you so that you don't have to worry whether you migrate your database later onto MariaDB or Microsoft SQL Server. You change database without changing your source code. That's the power of ORM because you don't have to worry about the source code. So if you want to query the primary key, which is our ID, it's as easy as a single line of code and you get your result. No fancy select from or something like that. Even join statement is quite easy. Even inner joins, outer joins, you don't have to worry about complex SQL statement. It's handled by the ORM engine. So instead of writing maybe 5 or 10 lines, it becomes just a single line of code. Means your source code becomes much easier to implement. Okay, so let's try to execute this API just to demonstrate. Okay, so I have here I'm calling a save. So if you look at, once you are saving information, normally it's a post request. So we will call this API customer for the post, and then I am storing this JSON data. Okay, I want to store my name, email, password here. So my username is Aguel, and you can see it in this format like that. Okay, so let's try to save this one. And we will also take note that we will be implementing, remember I discussed about the bcrypt to store the password. So let's go to the database. Okay, let me just delete this one first. Okay, so empty. So let's say I want to execute, select just the ID, name, and password. Nothing, it's empty at the moment. So let's try to call the API. I want to store this customer into the database by calling the API. But take note, our API requires authorization, so we have to pass the token. Okay, so we have to pass the authentication token. Now let's try to save this database, this record. So I have name, email, mobile number, and I want to store it into the database by calling our API. And also we can monitor the transaction from here. Okay. And first, you can see here in API log, it's a success. and I was assigned this particular ID for my customer, for my record. And you can also hear also the tracing of your API. So it took just 607 millisecond, 2 millisecond for the authentication resolution, and the actual saving is just 500 millisecond, below 1 second, very fast. Okay, so I have here the ID. Now let's try to take a look at the uh, database. Let me execute. Okay, can you see this is the ID number C226. We'll just pull it. Can you see this one C226? This is the ID, and this is the name. And you can see the password is stored in bcrypt. It's not stored in uh, it's not stored in plain text. That means nobody can actually hack your password, or nobody can see your password. It's being hashed using the bcrypt authentication. It's included in our prototype application. Now, if I want to query, by the way, I will explain to you what is this very large string. I will explain that later on. Now, if I want to query, let's call another API here called the query customer. And I want to query and pass the parameter ID is the C226. Okay, so this is a get. And this also requires authorization to be able to call because this is in the secure endpoint. Let's try to call the API. I have success. Remember, we use the same format, code, description, date, and data. And we have the data returned here with the information. Okay, now you can use this in your front end to actually execute to display in the front end. Okay, so that's how you save, and that's how you query. Single line of code for saving and querying because we use the ORM. So it's much efficient and much flexible to actually call. And also, just to show you the lag, remember when we execute the save customer, you can see the actual query statement being translated here. Can you see this part? Here, executing, and you can see the lag. That's the SQL statement generated. Okay. Question so far? Maybe it's just too complex to explain. Any questions so far?
Any questions, Lo? Brian?
It's okay so far.
Okay, I will show you what it looked like if we deploy in the production environment. Okay, so let's start with user info. Okay, so I will stop. Let's stop first the nuts. Okay, so we have empty here. In production environment is a little bit different because remember earlier we used the HTTP. In production environment, we have to use the HTTPS, the SSL. So let's try to build in a production environment. We'll be using the Docker image to create a Docker container to run our application. I think I showed this earlier. And here I will also show you how to access this information. Remember, as much as possible, we didn't want to expose the CLI from the outside. This is production environment. So I will show you how I will demonstrate to you that now you can access everything from the dashboard. you can monitor every aspect of your application from the dashboard. Okay, so in the meantime, while waiting for the Docker to be built, so now remember I'm using the development environment. Now I change to production. Okay, so you can see here default group is production. Production is now using the HTTPS here. Okay, so we will switch to production mode, and I will also show you that. Okay, so let's try to verify that the services is running in production mode. Okay, so we have the API, service gateway, we have the traffic. So first thing first is, let's see how many services do we have running on what is first, let's try to take a look at. Remember, in production environment, we have the reverse proxy. Reverse proxy is your traffic control. Once you have the environment, now you can access your reverse proxy from the dashboard. Let's try to access from here. This is your traffic environment. So you can see it's using HTTPS. If you use the HTTP, you will be redirected to HTTPS. And I have here how many success calls, how many are errors, if there are errors from outside, how many routers that I have. And you can see if I go here, you can see here that I have the gateway service API. Remember, the gateway service API is a Docker. You can see this Docker logo. The gateway service API is our entry point. That's why it's you can visible from here. This is the gateway. Okay. Now you can also expose our. Let me show you. Maybe you're not familiar, but most of big companies, they have a metrics monitoring like a New Relic. I think you might be familiar, New Relic and Datadog. You can also expose your application like here. I expose to Datadog, and I can access the Datadog from here. You can see the dashboard. I can go to the dashboard. Here. So I only have one node. I have total of services, a total request, free memory of the node, how much is the uptime, CPU utilization. You can monitor every aspect from using the Datadog. Datadog is a commercial. They also have the free if you have only limited of your server. But this is only one example. You can monitor also the traffic from here. So if there are like error in the request, you can monitor from here. Okay. So everything on the dashboard you can see from here. You can monitor from the dashboard or the Datadog. Now, what about tracing? So what we can do if we want to execute is we have a handler for the tracing. Remember earlier we used the console for tracing the API calls. But the problem is we want to avoid the API calls being monitored from the console. So we will use the external application called Jaeger, this one. And I will demonstrate that to you. So let's try to start Jaeger first. So right now we don't have no Jaeger running. So all we have to do is just start Jaeger and we can actually monitor our APIs from here. Okay, let's verify Jaeger. Here we have the Jaeger tracing already running. Now let's try to execute some calls. Let's go to the Jaeger dashboard. Okay, So this is our dashboard. Earlier, we can see the jigger, the API monitoring from the console, but this time we will try to use the UI, the dashboard, because we don't have access to the console. So let's try to call some API. Let's say earlier we used the user node info. Okay, so we have success. Let's try to call user info success. Now let's try to do the tracing. If we refresh here, uh, let's try to enable first. I think we forgot to build. Let's see. If you can see here, we are not seeing our API, so let's try to do the build first. Uh, in the meantime, I want to explain first. This is the metrics. There are three types of metrics that you can monitor. First is the system metrics. System metrics means like how much memory you have or how much CPU utilization. These are what we call system metrics. There is also the application metrics. For example, how many total requests, how many services is running, what is the total number of nodes. These are application metrics. But there is a third kind of metrics, which is your business metrics. So for example, if I want to monitor how many customer registration within 1 minute, like I want to get the average, how many customer registration in average of 2 minutes or 1 minute, you can also define a business metrics and you can expose that. Let me show you that. You can create a metrics from here. Okay, so look at this part. I can create a metrics. I want to call it this one, SIOI customer registration. So every time, if you look at here, every time I save a customer, this is the method. Every time I save a customer, it will actually call the metrics broker called SIOI customer registration. So it will create an increment every time there's a new customer registration, and it will be broadcast also to the metrics dashboard. That's why if you go to the Datadog, you can add here, you can see from the list, you can see here SIOI customer registration. So you can see that there is only one at the moment. and you can get the statistics. So what this means, like how many likes, like if you are like something like the Facebook, how many likes in 1 hour, or if you are in YouTube, how many views in 1 day. You can create your custom business metrics by exposing your metrics into the dashboard, and you can create a graph, or it depends on what you want. You can create a static value here, or you can graph how fast. You can create your business metrics from any time. You can expose. This is one of the feature of this framework. That's why I put an example here. For every customer registration, it will register a count. You can create here a rate. If you want to create like every 1 minute, how many customer registration. So you can control from here. Okay. So this is what we call a business metrics. Aside from the system metrics, CPU, memory, you have the application metrics, number of requests per second, total request service count, number of errors. There's also the business metrics of how you want to monitor your business application. You can expose it as well, and you can create a graph. So you can create as many graph here. You can see from top. How do you want to visualize the information in your metrics? Okay. Now going back. Okay, it's running now. Hopefully we can find. Let's try to call the API. Hopefully we can see. Otherwise, we can use the development mode to show. This is correct. It's not showing, but I will show you how it will be presented. I think I'm using the. Okay. So you can see here. Okay. So for example, I try to call the gateway. So I think this was the okay. So if you want to trace how your API is working, you can use this particular dashboard to monitor your API. So for example, I try to call the user information node. The performance in production is much faster. It's just 18.94 milliseconds. And I can open up and you can see the tracing. So first, it goes to the authentication, how long? And then it goes to the user info action, just 1.1 millisecond. It's faster in production environment. So you can trace, like if there's an error somewhere, you can actually see where it is happening, and you can actually monitor from here. Let's try to simulate an error. Let's say the node user information, remember the user information requires an authorization. So if I don't want to be authorized, which will actually give me an error 401. Okay, see this error 401, and you also can monitor the error 401. That means the user is not authenticated. Now, if you look at the Jaeger, it should be able to show. Can you see this part? You can see that this particular call, the same as this one, the same API call, but this one is only stopping in the gateway part because it generates an error. This one, remember an authorized error? You can see here, error 401. So you can monitor your API from this dashboard. If, like for example, why am I getting this error? You can trace that it doesn't actually reach, unlike the previous one, it goes from authentication server service to the core service, and then the gateway authentication to the core. This one already stops because of the error 401. No authentication was provided. Remember error 401. If you might be wondering why is it not reaching the out service only in the gateway? Because the error 401 implies here no authorization token. So what this means is that it's just validating that there was no token and there was no validation whether the token is valid or not. Okay. Now, just to demonstrate what's the difference, this one stops at the gateway. I produce another error. Okay. Let's say I want to specify a token, but the token is invalid. So I put XXXXX here. That means I specify a token, but the token is invalid. Earlier in the scenario, there was no token. That's why it stopped at the gateway. This scenario number 2, there is a token, but this is an invalid token because there's an XXXX here. So if we execute this API, okay, now you can see that the error just changed. Authorization token invalid. Now, if I do the search, the difference between this one and the other one is now it enters the authentication because there is already a token, but the out service denied because there's an invalid token after validation. Are you following? What's the difference? One is without token. The other one is there's a token but invalid. That's why it goes to 2 services. One is the gateway and then goes to the out service. The other one, it stops at the gateway because there's no token at all. While the third one is completed and successful, and it's very fast. You can monitor every aspect. Can you see the difference between the 3 requests? Any question?
None, sir. None so far.
Okay. So, okay, so this is the framework. Now, if you want to save like purchase order, sales order, you can just simply, very basic, just create your data model to represent the database, and just you can call the API based on the SQL command, SQLized command, ORM. So very easy. And now I have I have also provided a way how to define here an example how to define whether the endpoint requires authentication or not. And if it requires authentication, how to validate the token. You don't have to validate, it's handled by the out service automatically. And all you have to do is just define the logic. So here we have an example of how to save into the database and how to query also from the database. So this is a good starting point. Don't worry, you will not learn it overnight. Just learn it on the process. Study the source code. I will provide you access You can download the source code in your local machine. And by the way, I forgot to mention, if you want to deploy to the Kubernetes cluster, now you can define a policy. I have already provided also. So here we have the K8S. K8S is a shortcut for Kubernetes. Okay. So here, like for example, I have here gateway service. How many gateway service do I have to specify? You can define the policy from here. So for example, here, gateway. There are two gateway service running, at least, and in the authentication service also two. I can define in the core service. This is what we call a deployment policy. You define how your services will behave. You can define policy here how to auto scale, how to define auto scaling, and it will be handled by Kubernetes automatically. You don't have to worry. All you have to do is just define the policy of how the service will behave. Kubernetes will do everything for you. You will just deploy, and they can find each other. And here we also have nuts. In this case, nuts is only one. Only one nuts is running, but of course you can define as many nuts as you want. And you also have the services, core services running. Okay, so I understand it's very confusing. It's very difficult to understand everything in one session. So the best way to learn is to take a look at the code, run. You can run the code on your local machine or from the server, learn how it behaves, try to understand the API, the functionality, molecular framework, this one, the sequelize. By the way, the sequelize, although we use the ORM, like in this example, we use the user create, but if you really want to use the native SQL statement, you can also do that. So we have an example here, how to execute row query, select statement. If you want to do manually, that's fine. If you want to, if you want to update the record manually, you can do that as well. That's fine. No one is preventing you from doing the raw SQL statement, SQL statement. But if you want to make it more portable, flexible, then you can use the ORM API. So this is flexible, which depends on how you want to generate. Oh, and by the way, I forgot. Uh, in our database, you will notice that the primary key is ID has this format. Before, traditional format is the sequence. Like every time you insert a record, it's 1, 2, 3, 4, 5, 6, your primary key. In modern distributed application, we don't want to do that anymore. But it's not mandatory. It's up to you if you still want to use the sequence. It's still available. But in the modern cloud computing, we use now the UUID. We call this the UUID format. That's why you can also find it here. UUID version 4. This is the standard way. I'm not sure if you're familiar with blockchain, Bitcoin. You have your Bitcoin address is something similar to this format. This one. This is now the standard format generating a unique identity. UUID, it means universally unique identifier. This is to identify each object, element, or anything that you want to be uniquely unique. We use now the modern approach of using UUID. But again, I want to mention, if you still want to proceed with sequence, using trigger to insert the sequence, 1, 2, 3, 4, 5, you can use, feel free to use, but the recommended way is for all primary key identifier is to use the UUID version 4. Okay. Now you can explore, you can do some research, and you can understand why is it very important to use this format. This is a randomly generated ID. Question: if I use this one and then generates a random identifier from time to time, is there a way that this one gets conflict, like generate to the same ID? The answer is almost impossible. According to statistics, if you generate 1 million UUID every second 1 million UUID, you only have a chance of a collision. Collision means the same conflict once in every 30 plus years. Once in every 30 years. That is if you generate 1 million UUID every second. So that's how uniquely it is generated. That's why this is the recommended format. But of course, feel free to use if you want. But I think that will be subject for discussion with the project manager if you want to use the sequence number for your data. But again, for the password, never store plain text. Always use the hash. And the recommended hash is the bcrypt, and it is already provided with an example in our API source code. And another important thing, if you look up here, most of us, when we define database connection, we specify the connection in several ways. Number one, sometimes it is hard coded in the source code. That's not recommended. Sometimes it is put also in a configuration file external. Sometimes it is also stored in the database, also external database. That's also not recommended because the fact is, if I have access to the database, then I have access to the connection. If you use an external file, anybody can probably have a way to take a look at the database connection and just connect to your database. So how are we going to supposed to configure? We use an environment variable. That's why if you look at the example, you can see here environment. In production environment, and let me show you that. And for production environment, we don't want any trace of database configuration inside. Instead, we inject them as environment variables at runtime, meaning like you can create a script to inject a variable. I think everyone is familiar with environment variable already. Like you have like the path. You do it like this. You have the that's example of environment variable, but you inject it at runtime rather than put it in a configuration file or something like that. Otherwise, if you put it in a database, but again, you can feel free to use if you want to use external file, configuration file, that's much better. You can use it in database. That's much better, but never hard code in your application because if, for example, there's a compromise and you need to change the password without downtime, you can just inject the new credentials or maybe new database address somewhere else rather than redeploying your application over again because it's hard coded. So again, do not hard code any database connection in your source code unless you are using the environment development environment where you can put here something like this. But it takes always put a source code wherein you prioritize environment variable to inject the value of your database connection. How is the Cold Fusion right now? How is it configured?
It's it's hard coded, sir.
Never hard code database connection. try to use external away. So every time you change, like for example, this one, if I want to change, for example,
Yes.
maybe username or password, I don't have to redeploy again or restart the server. I can just inject the value. So that's one of the disadvantages if you are hard coding. So try to avoid that as much as possible. And sometimes also it's very easy to inspect the code and you can see it being injected in your application. So try to avoid as much as possible. Okay.
Yes,
Any
sir.
questions so far? I think that's all the basic concept. I cannot basically explain everything from very low end. I think we covered most ORM, response data, protected API. We have here the gateway. You define the protected whether authorization is required or not. Uh, Docker, we have already implemented. Docker commands is already here. I think we covered most, but the best way to learn is really by practice. So try to copy the source code, run it, observe, study the source code, and everything. Any questions so far?
Uh, Ryan, do you have?
So far, none. But I think as we indulge to the development or the studying part, I think more and more questions would come up. Uh, is it okay, sir, if we could DM you if ever during our studying?
I think, yeah, I think hopefully Barbie-san or Josephine will create a group in Slack so you can question. But it's something like this. The best learning curve actually is I'm not really something like it's not that I don't want to help, but this is a way of motivation. The best way to actually learn is if you discovered by yourself. Because normally, if unless it's quite difficult, you can feel free to ask me. But I would recommend, like, if there's something that you want to figure out how to do this, try as much as possible to learn by yourself because normally those actually uh, information that you got from someone else, they will be stored in a short-term memory in the brain. Yes, you can recall it, but next time it happens again, sometimes you cannot recall. But those that you discovered by yourself normally sticks into the long-term memory. That means it absorbs, it becomes part of your brain, and you can learn more. But don't worry, feel free to send me questions if you have. But as much as possible, try to learn, try to discover on your own, unless you're already in the roadblock. That I mean, roadblock means I already wasted 2 days or one day, and still I cannot figure it out. Don't waste your time. Ask me. But if you just after 5 minutes and you cannot do it, try to learn, try to discover. Because one important thing uh, that is beneficial if you discover on your own, actually along the way, when you discovered it, you discovered also something else together with what you are actually trying to learn. So that's very important. But I hope Josephine can create a group in chat wherein we can actually uh, a separate group where we can actually share information because I also want to share the URL, the link, credentials for the database, credentials for the Linux server. I would like to share in that particular group, but I don't have access at the moment. Babison, I hope you can help us create a separate group. But again, I still would recommend try to discover, try to explore on your own. Unless you're already spending so much time, then don't waste your time. Just ask.
Okay, sir. Actually, I meant to point that out that if ever we encounter a dead way, that's what I'm trying to emphasize if ever we have a dead way, maybe we could ask directly from you.
Yeah,
So
yes.
as what you have said earlier, yes, sir, we will do our best to, since all the devs are hardworking also. We will do our best to learn those things. But there are just times that, like as what you have said, that maybe we already spent 2 3 days. Sometimes it's weeks. Uh, Maybe we could just do the shortcut and ask you directly if it's
Yes,
okay.
don't waste your time if you're spending too much time already.
Yes, sir. Okay, sir.
Any
Uh,
other question?
any other question?
No more questions here, sir.
Okay. I'd like to talk something about this project. And today, Alex talked about a lot of technology things, but it will be categorized one in the environmental part, and the other one is the API programming structure. So I think the Chris and maybe Josephine also, it's better to understand the whole picture. Of course, not necessary to be set up whole uh, structure around with the own machine, especially like a Kubernetes. I mean, the understanding of Kubernetes is quite uh, maybe quite difficult if you are not a network engineer. But let's say at least Docker, maybe start from Docker and on your computer, do the experiment to feel what is happened. On the other hand, rest of the programmer maybe concentrate for the API programming logic. At almost the end of the today's session, Alex was showing you about the database and the API and how to connect. So this is quite important in the beginning of our programmer. Then the I mean the faster way to understand the whole, catch up the development is try to set up the environment. The testing environment on your PC. I mean the server side environment will be let use the Alex prepared virtual server. But your side is, the access from your PC and how to access to the the molecular environment, and the how to access the database, and how to write the API logic. As Alex mentioned, the Postman is recurring to your Windows-based PC. Use the Postman to write the sample code, the sample API code, then the access to the server-side API. Maybe this is the starting point. Then the second is the writing some more API logic. then you can call your API.
Okay, sir. Understood.
Yeah. And I like to talk about something about the ORM. It's OR mapping. And some people call OR mapping is quite useful, and they can make the database system without SQL knowledge. Or other people say OR mapping is the generating the quite the how to say unproductive because of the automatically generate SQL code is less productivity than let's say my own own optimized SQL statement. Some people say, and maybe both are not really correct. The, using the ORM, you still, I think all our programmers already knows about SQL statement, but when you use the ORM, you have to think about how your programming code will generate the SQL statement. So, and then you also imagine about the database structure and how to how your programming code will generate SQL statements. Sometimes some situations the ORM generated SQL code may be better than the typical programmer's SQL statement, or some people sometimes no. So you also all programmers get familiar with ORM, and you maybe think about how to writing the source code, and then what kind how the ORM generate the SQL statement. This is the one important point that the I like to request to the programmer. And the last one is the UUID. UUID was created for distributed database system. The distributed database system is the not just the clustering system, but let's say they have a the database system in the a lot of the place, but it will be finally synchronized to the same data. It's just like Ethereum or the Bitcoin data. When that kind of the distributed database structure, when you create the data in one database with the primary key, this other people is all, accessing to the other database to creating the primary key. So it must be my primary key and the other guy's primary key in other database cannot be the same, because finally all data will be merged into this one merged into the all people's database. When that kind of the situation, UUID is quite useful because you don't need to think about other people's primary code. You just use UUID to create your primary key. Then other people also use UUID to create the primary key. Then it will almost never to be duplicated. This is advantage, but we have to be carefully think about, because we are thinking about MySQL MySQL has the the MySQL database has the function to generate the running number automatically. And actually, the SIOI system does not need to think about the distributed database situation. But on the other hand, UUID is a quite new technology. So we should also study and think about, will we technically think about advantage and disadvantage. That is from my request. Any question, Chris? Hello.
None so far, sir.
Okay. Yeah. Is it programmer computer has the Postman? Not yet.
I do have, sir, but I'm not sure if Lou and Brian has posted.
Yeah. Maybe. Yeah. Please, Chris, please share the Postman knowledge to the other programmers, because if he without the program to test the API, we always use the Postman.
Yeah. Yes, sir.
Yeah. And well, the current way CodeFusion is the user interface and the business logic at the same place.
Yes.
Yeah, this is the let's say the short-term productivity. They have advantage, but we are always having the trouble with the testing. I mean the programming. I mean product testing because business logic was implemented into the user interface. That's why we must through the UI to do the business logic testing, right? That's why somebody we need somebody to operate the system actually. But most of the business logic we develop in the API side. The API can for the API business logic is right or wrong. We can make the testing program. We can use the testing system to evaluate the API. Send the parameter to API, then get the return code, then evaluate whether this API is right or wrong. So this is the one of the very big advantage. Before we, I mean, we don't need to operate the SIOI actually, but we send the parameter to API right way, good way, or the big amount or quite small amount. A few cases, we think about the testing case and then prepare the testing data and then run the testing program. Then even though API is the total number of the API is maybe few hundred or thousand, but the testing program will evaluate the quality of the API automatically.
Okay.
Yeah. So and also somebody also saying if we go for this way of the development, we could make the testing program before actually develop the API program. Do you know what I mean?
Can you repeat, sir?
yeah. Uh, before develop the application,
Okay.
we have to make the API spec, API specification, right? Interface.
Yes, yes.
What kind of the parameter set, and then
Ah,
what kind of the output return. Then
okay.
yes, then we can if the API set is defined, then the next step we could define the testing case. What is the middle the middle the middle value and the upper maximum value or lower maximum value of the correct data, or we can set the too big value that it should be error case, or too small value that it should be error case, or something like that.
I see. Okay.
Yeah,
So the API side must be developed first.
yeah. Define the API spec, then define the testing case, even make the testing program, then start the actual API development. So after you create, after programmer make their own API program, then run this testing case, and
Yes.
then it will say shows the it will show by the testing program whether it is right or wrong.
Mm-mm.
Yeah, and also the one good thing of the microservice architecture. Before that, the monolithic applications structure, we have to combine all the API source code into the one mode, binding into the one file, and then link with the API. Link with UI. Well, actually, UI was, the business logic implemented into the user interface. So
Mm.
until finish all the parts, then we can start testing. But the microservices, the every API can be tested alone.
Mm.
So if 4 or 5 programmer develop the API, let's say you develop quotation, you develop the sales order, or you develop the purchasing order. And everybody makes their own part of the API. Of course, some of the APIs are common API. And
Yes.
I think the common API will be maybe Chris or chief engineer will be organized.
Okay.
Yeah. Anyway, before development, define the API first, right?
Mm-mm.
Yeah. Then after define the API, then they go into the coding. So after finish the coding, they can test their API one by one. It's very easy.
Okay.
Am I right, Alex?
That's correct, Ma'am-san.
Yeah. So of course sometimes the after when the UI side user interface called API, and then actual system running, sometimes maybe unexpected things happen. But this is the exceptional case. So I thought maybe use this way, the total productivity, the short-term productivity will be the longer than the core fusion way. But for the long term, we could our the API resource can be reused for the lot of the things, because API has the portability. Yeah, that's it.
Any other question?
No more, sir. No, no questions here.
Oh, I think Josephine already created a group in Slack. And
Yeah.
also I have posted all the server information and links. So feel free for everyone to access. Now,
Um,
yeah, I will have the server running as much as possible. And for those who are new to Linux, for those of you who wants to learn, please let me know if you want me to create another dedicated Linux server for learning. I can create one for you. Just let me know.
okay, sir.
Okay, I think that's it, Mami-san. I will stop the recording now.